Welcome to Ask and Learn.
So for this problem, we have a circle with radius r, and it's centered at the origin. So what we have is x squared plus y squared equals r squared. And we solve for y, and we say that y equals plus or minus the square root of r squared minus x squared. So we know that the top half will be the positive square root, and the bottom half will be the negative square root. So the base that we have is 2 times r squared minus x squared. And that'll give us the whole base length of our isosceles triangle. Then the height is the same for every triangle, so the area of one cross section is going to be a of x equal to 1/2 our base, which is 2 root r squared minus x squared, times our height, which is going to equal our height times the square root, height, because the 2's will cancel, so just height times the square root of r squared minus x squared. Then we know the circle intersects at the x-axis at x equals negative r and x equals positive r. So that's how we're going to integrate. We can pull out the h, and we also know that it's symmetric, so rather than going from negative r to r, we can just go from 0 to r and multiply it by 2. So our volume is going to equal 2 times h times the integral from 0 to r of the r squared minus x squared dx. Then for part b, what we find is using this, we can square both sides. We get our equation of a circle again. So since y equals the square root of r squared minus x squared, that's our upper half of the circle of radius r centered at the origin. So the way that we can write this now is going to be the volume, once again, of 2h. We have that same thing, but that's actually going to end up equaling 2h times 1/4 of pi r squared. So then the final answer will be 1/2 pi r squared h. And we were able to do this by replacing the integral with the area of a circle, which we know to be pi r squared. And then we multiplied that by 1/4 since we have half of the half circle.